So now if you recall anything at all about our inverse functions, we can use these properties of inverses to help us get the graph of the function like logarithm base 2 of x. Now recall our properties of the logarithm were that f of 1 is equal to 0 if we have a logarithm. Well, certainly, right? We're saying here that our function logarithm base 2 of 1 is equal to 0. We can use that. It means that when x is equal to 1, y is equal to 0 is a point on our logarithm graph. F of 2 is equal to 1. Again, recall this was from our property that said the logarithm base a of a is equal to 1 because 2 to the first is equal to itself. And so this is the kind of graph that needs to go through the point 2, 1. F of 1/2 should equal -1. And this is going along with our exponent rule there. Logarithm base 2 of 1/2 has to be -1, and that's because we know 2 to the negative first is 1/2. So 1/2 -1, that's way down here, there it is. 1/2 -1 here. All right, so we've got some basic points, but let's go back. This is the reason that we want to talk about these inverse functions. There's a couple of things about inverse functions. Recall the exponential function y equals 2 to the x. In that exponential function, we had a horizontal asymptote at the line y equals 0. And our range of this exponential function went from 0 to infinity, while our domain of this exponential function was the kind of domain that went from negative infinity to positive infinity. Okay, well, because they are inverse functions, y equals 2 to the x will have a domain of negative infinity to positive infinity, so y equals logarithm base 2 of x will have a range of all real numbers. The range of the function y equals 2 to the x is 0 to infinity, so the domain of the inverse function will be all x greater than 0. In other words, from 0 to infinity in interval notation right here. So that's good. Finally, there's this horizontal asymptote for the exponential function, remembering that all of our x and y values are reversed, right? Here was 0, 1 on our original function, our exponential function, right? Here was the point 1, 2 for our exponential function. Here was the point -1, 1/2 in our exponential function. All of the xy values exchange, so our horizontal asymptote y equals 0 becomes a vertical asymptote at x equals 0. And what will happen here is that this logarithmic function will come along the vertical asymptote at x equals 0, pass through the 3 points, 1/2, -1, 1, 0, and 2, 1, and then head off in what we figure is a logarithmic graph function form. Right? What's happened is that it's almost as if, right, you can look at these different points here. 2, 4 becomes 4, 2 on our new graph. 3, 9 will become 9, 3 on our exponential function. I missed a little bit there, but you get the idea. This whole function right here should pass through points that mirror exactly what was happening in our exponential function. So that's kind of cool. And this is the way that our logarithmic function will look.